or not. State your reason if it is a polynomial. Example number 1. 5x Yes, it is a polynomial. Next, we have x squared plus square root of 2x plus 1. The correct answer is not. The expression is not a polynomial because a variable is found inside a radical symbol. How about 2x to the power of 3/4 plus 2x squared plus x minus 1? The answer is not polynomial. An expression can't be considered polynomial if it contains a fractional exponent or the exponent of one variable is not a whole number. How about this expression? Square root of 3 x plus 2. Yes, it is polynomial. No variable is found inside the radical symbol. Next, we have 3x cubed plus 1 over 5x squared minus 2x plus 3. The expression is not polynomial because one variable appears in the denominator. Lastly, we have 2x to the negative 4 plus x cubed plus 3x squared minus x minus 3. So, the expression is not polynomial because one variable contains a negative exponent. A polynomial is an expression of one or more algebraic terms of which consist of a constant multiplied by one or more variables to raise a non-negative integral power. In other words, in a polynomial expression, no variable is inside a radical symbol, no variable has a fractional exponent, no variable is in the denominator, and no variable has a negative exponent. Suppose you are asked to make an open box from a 20 by 12 inches cardboard. To make an open box, you are required to cut small squares from the four corners and fold the following line of the cut squares. The folded side will be glued. The volume of the resulting open box illustrates a polynomial function. The volume of a box is length times width times height. That is, volume is equals to the quantity of 20 minus 2x times the quantity of 12 minus 2x times x. This is a polynomial function in factored form. Multiplying the three factors, we have 4x cubed minus 64x squared plus 240x. A polynomial function in standard form. Polynomial is a function of the form p of x is equals to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x n minus 2 plus ellipse plus a sub 1 x plus a sub 0, where a sub n is not equal to 0. N is a non-negative integer. A sub 0, a sub 1, and so on until a sub n are real numbers called coefficients. A sub n x to the n is the leading term. This is the term with the highest exponent. Its coefficient a sub n is the leading coefficient, and its degree n is the degree of the function. The degree of the function with the highest power of variables of p of x. A sub 0 is the constant term. There are various types of polynomial functions based on the degree of the polynomial. The most common types are zero polynomial function with degree 0, or that is p of x equals to a x to the power of 0, or just a. We have also linear polynomial function of degree 1, written as p of x is equals to a x plus b. We have also quadratic polynomial function of degree 2, and written as p of x is equals to ax squared plus bx plus c. We have also cubic polynomial function of degree 3, written as p of x is equals to ax cubed plus bx squared plus cx plus d. And last, quartic polynomial function of degree 4, written as p of x is equals to ax to the power of 4 plus bx cubed plus cx squared plus dx plus e. Other than p of x, a polynomial function can be written in different ways. The following are f of x or y. Given this polynomial function, 3x to the power of 4 plus 2x minus 1. The first term is the term with the highest exponent, hence 3x to the power of 4 is the leading term. 3 is the leading coefficient, and 4 is the degree of the function. And the constant term is negative 1. How about this example? F of x is equals to x squared plus 4x cubed minus 5x plus 6. Looking at the function, the terms are not written in standard form, since they are not written in decreasing power of x. Looking at the function, the terms are not written in standard form, since they are not written in decreasing powers of x. To determine the leading term, just look at the term with the highest power of x. In this case, that is 4x cubed. The leading coefficient, therefore, is 4. And the degree is 3. So it means that this is a cubic function. The constant term is 6. Next example. The function of y equals the quantity of x plus 2 times the quantity of x minus 3. It is written in a factored form. We need to write the polynomial in standard form to be able to determine the leading coefficient, leading term, degree, and constant term. By multiplying the two binomials, we have the function of y equals x squared minus x minus 6. The leading term is x squared. 1 is the leading coefficient. 2 is the degree of the function. And negative 6 is the constant term. Since the degree of function is 2, this is a quadratic polynomial function. Now, it's your turn to find the leading term, leading coefficient, degree, and constant term of the function. I will give you 5 seconds for each polynomial. The first polynomial is f of x equals negative 2x. The leading term is negative 2x. The leading coefficient is negative 2. The degree is 1 and the constant term is 0. The next polynomial is y equals 1/2 x squared plus 2x minus 1. Yes, the leading term is 1/2 x squared. The leading coefficient is 1/2. The degree is 2 and the constant term is negative 1. How about this polynomial function? P of x equals 1 plus 3x minus x squared plus 4x cubed. Your answers are correct if your leading term is 4x cubed. The leading coefficient is 4, the degree is 3, and the constant term is 1. And last, how about y equals 1/2 x minus 5? One-half x is the leading term. 1/2 is the leading coefficient. 1 is the degree of the function. And negative 5 is the constant term. I know you get all the correct answers. Is it easy? If you noticed earlier, the volume of our rectangular box is V equals the quantity of 20 minus 2x times the quantity of 12 minus 2x times x. This is a polynomial function in factored form. Its equivalent polynomial function in standard form is V equals 4x cubed minus 64 x squared plus 240x. You have learned that in your grade 9 that a function is written in standard form if the exponent of the variables are arranged in decreasing order. Like this function, the exponents are 3, 2, 1, and they are arranged from biggest value to smallest value. To write function in a standard form, remember this. Write the term with the highest exponent first. Write the terms with lower exponent in descending order. Remember that a variable with no exponent has an understood exponent of 1. And lastly, a constant term always comes last. Example: y equals 1 plus 2x minus 4x cubed plus x to the power of 5. To write this function in standard form, we will write the term with the highest exponent first, and that is x to the power of 5. Arrange the exponents in descending order so that the second term will be negative 4x cubed, which will be followed by 2x with 1 as its exponent. And 1 is the constant term, so it will be written last. Therefore, our polynomial function in standard form is y equals x to the power of 5. If the function is written in factored form, to rewrite it to standard form, you must find the product first. Here, you are going to use your prior knowledge in multiplying monomial and binomial, and others. Example: y equals m times the quantity of m plus 2 times the quantity of m minus 2. To write this in factored form, get the product of the sum of difference of two terms. And that is m squared minus 4. Multiply m with m squared minus 4 using distributive property, and the standard form is y m cubed minus 4m. On the other hand, to write polynomial function in standard form to factored form, you simply use your knowledge in factoring polynomials. In writing polynomials in factored form, the function must be completely factored. Write the polynomial y equals x cubed plus 8 in factored form. Since this is an example of sum of cubes, use the techniques in factoring sum of cubes expression. Hence, our factored form is y equals the quantity of x plus 2 times the quantity of x squared minus 2x plus 4. Another example: f of x equals x cubed plus 4x squared plus 3x. Since x is common to all terms, we can easily factor this out, leaving x squared plus 4x plus 3. Using the concept of factoring quadratic function, we can factor this further to the quantity of x plus 1 times the quantity of x plus 3. So our factored form of the polynomial is f of x is equals to x times the quantity of x plus 1 times the quantity of x plus 3. Just apply your previous knowledge on factoring polynomials and rewriting polynomial to factored form will be a lot easier. Practice rewriting polynomials in factored form and standard form. Just choose the letter that best answer the question. You are given 10 seconds to answer each item. What is the standard form of y 8x squared plus 4x plus 3x to the power of 6 plus 3? You are correct if your answer is letter D. What is the factored form of the polynomial function y equals 2x cubed plus 14x squared plus 20x? The correct answer is letter D. How should f of x equals x cubed minus 64 be written in factored form? The correct answer is letter A. What is the standard form of y equals the quantity of 3x plus 1 times the quantity of 2x minus 7? You are correct if your answer is letter A. To review, let us complete this paragraph. We are to fill the blanks with the choices provided in the box below. Do this in 15 seconds. Now, let us check your answer. A polynomial function is a function that involves only non-negative integer powers or only positive integer exponents. The degree of any polynomial is the highest power present in it. In the cubic polynomial function, y equals 4 plus 2x plus x cubed. X cubed is the leading term. 4 is the constant term. 1 is the leading coefficient, and 3 is the degree. The terms of a polynomial may be written in any order. However, if they are written in decreasing powers of variable, the polynomial function is in standard form. If the polynomial is written as a product of irreducible factors, the function is written in factored form. In writing polynomials in standard form, write the term with the highest exponent first, and the constant term always comes last.
There you go, graded learners. I hope that this video will help you in understand our lesson. Always remember, mathematics is easy and exciting for those who are willing and eager to learn. This is Teacher Sherwin. Stay safe and God bless.